Hey team, it's video 12, your last video for Thursday. Hooray. We are back in our studio, so please open up our studio. And also, please open up the file that we saved in class today and that you also should have been working on in a previous video called practice2.r. Much of this practice we're not actually going to use today. We're going to, as they say, comment it out. And so we're going to take all of this stuff that we did. Yeah. We're going to take all of that stuff, highlight it, go up here to the magic wand menu. I know, it's so cute. And go comment uncomment lines. Ding. Now those are all commented out. So all that's left here is kind of the first two lines of script, right? Library tidyverse and CNTY read CSV counties.csv. So we are going to be using counties.csv again. However, before we do that, we are going to install a new package. How do you do that? Install packages. Yeah, okay. Sorry, it's late. I'm getting a little punchy. The package I would like you to install is called gdata. So we're going to go down here and say install packages. That's our function. Make sure you're doing this in the console window rather than the script window. Install packages, quote, gdata. Why do you use a quotation mark there? You use a quotation mark there because the function install packages takes a name of a package as its argument. Gdata is just a name right now. It's not a package. It's not an object. In any case, go like that, hit return, wait a million years because the web connection at my house is super slow. And you should have something like this. So it tried that URL, it downloaded 1.2 megabytes. The downloaded binary packages are in blah, 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 blah. If you get a message that says the downloaded binary packages are in, you're good to go. If you get a message that says that gives you some sort of fail, you're less good to go. I'm not quite sure why that's happening. We'll have to debug that. Some of you have older versions of Mac OS or older versions of R, and you might see a message asking whether you want to install from source. You should type N return. If you ever get a thing that says, "Do you want to install from source?" You do not. So just respond lowercase n return. But most of you should have had no problem downloading package gdata. Gdata is awesome. Gdata has a whole bunch of great functions that allow us to clean up our data. So that is what we are doing right now. We are cleaning data. You would be shocked and perhaps horrified to know how much of the time and effort of most statisticians actually goes into making data usable. The analysis, as you will see in a couple weeks, that stuff is easy. But first, you have to make sure your data are in a decent format and make sure that all the values in your data make sense. And that is called data cleaning. Okay, so we've installed gdata. We're now going to come back up to the script. An important thing to know in terms of our practice is that no matter how many packages you are going to use in a particular script, and no matter where you use them in the script, basically library statements that say, we're going to use this package, please make it available, those always go directly under the preamble. So in addition to tidyverse, in this particular case, we are going to library gdata. And you can see, right, that when I went to type gdata without quotation marks, it popped up as a potential completion. So that's good. That means it installed successfully. Okay, so we've done that. And then we're going to leave line 8, county gets read underscore CSV, the file name counties.csv, right? We know what that is. Now we're going to skip down past a bunch of stuff. That's all the stuff we did in class today. So some if-elses, some simple math, and then the write CSV command. And we're going to start, oops, that was a mistake. I did not intend that line to be there already. So we're going to start looking at the CNTY data and cleaning it up. Okay? Excuse me. The first function that I want to introduce you to is called filter. Filter comes from tidyverse, and filter basically cuts out or leaves in certain observations in your data set. So, for example, if we wanted to create a new version of county that only had observations from the state of Alabama. Sure, we'll try that. So filter, I'm going to put some information here in line 21. Filter, like that, takes 2 or more arguments. And the arguments it takes, first, you have to tell it what data set you're filtering, and then you have to give it a test. And if you want to, you can give it more tests, right? Test 2, test 3, etc. It will just do all of them. But mostly, I think it's best to just put one test per filter line. So let's say we want to just take a close look at Alabama. Let's call it AL, because, that's how you abbreviate Alabama. Again, we're making a new version of the data set, so we have to make a new object with that name. CNTY exists, or actually, yeah, CNTY will exist, but I want to filter CNTY, which is all of the counties, to give us only the counties from Alabama. So filter, that's our function, takes the argument. Filter takes the argument CNTY, right? It takes first the data set name, then the test. And you should be familiar with the idea of a test, something that is either true or false for every observation from class today. And the particular test that I'm going to give it is, gotta check the call names. I'm going to go down, just going to skip down here, make sure I have the right state call name. Call name CNTY. Oh, I didn't. Oh, I haven't sourced it yet. It's not in my environment. Do you see what happened there? I tried to go call names county, but guess what? The environment is empty. I need to source this file before I can do anything else. So source, blah, 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 county. Great. Now we try call names again. And go all the way back up to the top and find that the correct column name for the state is stname. So I'm going to uncomment this new line with filter. Go back. Okay. So again, I'm using the function filter to create a new object called AL that filters the data set called county with the following test. stname equal, and we always use double equals in a test, Alabama. Now, here's a potential problem. Am I sure that Alabama is written like that in title case? Maybe it's all caps. Maybe not. What can I do? I can come down here again and say, unique CNTY stname. That'll give me a list of all the unique values, aka how each state's name is written in the data set. Yes, it is written the way I think it is. Okay, so this filter function is now set up. AL gets filter. And what we're filtering is the data set CNTY. And the test is the state name Alabama? And we source it again. There it goes. So we can look down here to see Alabama. It should have all the same columns, but only the observations from Alabama. And indeed, that's correct, right? Where CNTY has 3,143 observations, AL only has 67 observations. That is the 67 counties of Alabama. We typically, when we're cleaning data, we filter out data that is unusable. So, for example, if when we do our survey, we get somebody who does the survey, but doesn't really answer any questions or is not a Drexel undergraduate, in that case, we have to filter out those people. And we would use, shockingly, the filter function for that. So that's what filter does. Now, what if we wanted to make a data set that included Alabama and Georgia? Then we use a fancy thing called, oops, I need to be up here. There we go. No, up here. My keyboard is having some issues. So let's say I want to do Alabama and Georgia together. I'm going to use the same syntax. Syntax is the sort of the same function in the sort of same pattern. But right now what I'm teaching is this next bit. So percent in percent. That is a special function or a special operator. That's an operator, percent in percent. It's just pronounced in. Pronounced in, but written like that. And then you give it a vector. And in this case, can you guess what the vector is going to be? Yes, the vector is Alabama, comma, Georgia. And because these are string variables, each of the things in our vector, and you notice the C says that's what our vector is. That's the list of values that it's okay for state name to take. So whereas in line 23, we get Alabama by filtering state name equal to exactly that, in line 24, we say, is the state name in this list of state names? Yeah, that's what the operator in does. So you can use the operator in to filter not down to one value, but down to several. So super useful, in my opinion. Let's see what else. How about a data set that doesn't include Alabama? We've decided Alabama is too weird for us. We want not AL. Filter, right? So we're going to use the filter again. We're going to filter the same thing. But instead of saying state name equal to or state name in, we're going to say state name not equal. So an exclamation point is an operator that reverses whatever comes with it. So double equal is equal. Exclamation point equal is pronounced not equal. Pretty cool, right? There, we've done it. That's our filter statement. We are filtering the dataset county such that the state name is not Alabama. So there we have it. I'm going to use the command dim to see what's in each of our new data sets. So dim AL has only 67 observations, but it does have the appropriate 124 columns. So when you're filtering, you should never lose columns. Dim ALGA. Oh my gosh, Georgia has a lot of counties. It really does. So whatever 226 minus 67 is, that's how many counties Georgia has. Dim not Al. Yep. So 3143 minus 3076. Guess what? That's going to be 67. Yeah. Yes, it is. It is. But notice always that the number of columns remains the same. And you won't always use filter You typically will use filter at the beginning of a script to make sure you're working only with the data you want to work with. But you will need to know how to use filter using these operators. So using the double equal test, using that special in, and using not equal. Other things that go in tests, like we did in class today, we had a test. Today in class, we had a test that used greater than or equal to. We had another test that used greater than. All right. Now it's time to create a new variable using some of the functionality from GData. In particular, I want to use the function trim, the function, and the function toUpper. So what I'd like us to do, actually, is to make a new, go back to our base county data set, and make a new variable called stcaps. I'm going to type this in, and you can see what you think it's going to do. toUpper, CNTY, $ST name. What's your guess? toUpper, the state name. Yeah, that's right. It turns it into capital letters. And this can be, in this particular instance, it's not that useful to us. I'm doing this as an illustration, but it can often be quite useful in the context of, for example, data where some people entered biomedical engineering in all lowercase, and some people entered it in title case, and some people entered it in et cetera, et cetera, et cetera, right? We want as much as possible to know that when we look at the data, things that have the same value will actually get grouped together and are, again, it's case sensitive, it's spelling sensitive. So if you have misspellings, or if you have changes in case between respondents, that's something that we as analysts will need to fix. And often we fix it by first putting everything in uppercase, because that just eliminates the case problem, because everything is in uppercase. Then we have to deal with spelling. So, okay, here's county stcaps. Going to source that again. I'm going to use a function now called head, where I just look at the first few values in the column. Head, CNTY, ST, caps. Hey, it did the thing. So that's good. You should know how to use toUpper. toUpper is a function that just takes a vector. In our situation, almost always that vector is going to be a column of a data set. I think the last thing that I'd like to show you is trim. And trim is very useful because it gets rid of extra white space. Now, we can't use the county data for this, so I'm going to make an example down here in the console window. I'm going to say x is equal to, right? So I'm creating a vector called x. I'm going to give it the following values: Amelia, and space, Amelia. Cool, right? Now, I may know that those three are all the same thing. R currently does not. So if I were to say table X, right, I would have one observation each of all three different values. So let's use toUpper. Now I'm going to say X gets, I'm going to transform X by doing X gets toUpper X. Can you guess what it's going to look like now? So now we have two values of Amelia and one value of it looks the same. When you see something like this, it's usually because there are weird, it's usually because there are strange spaces. Let's check. Yep. So toUpper took care of the difference between the first two observations. It did not take care of the extra spaces in the third observation. So we're going to say now X gets trim X. Let's try it now. Oh, that is what we want. And that is what trim does. If there's white space on either the leading edge or the end of a word, it doesn't erase white space in the middle, but it does erase leading and trailing white space. And that is often a big problem when people are allowed to enter their own data, as they will be in our survey. So I just want to put that out there as like a key data cleaning function. All right, you've survived. This is the end. This is the end of video 12. Thanks for sticking with it, and I will see you in class on Thursday.